So today we're going to look at a slope fields and separation of variables question. Here the question says to consider the differential equation dy dx equals the quantity 3 minus y times the cosine of x. We're going to let f of x be the particular solution to this equation, which has the initial condition f of 0 equals 1, or contains the coordinate 0, 1. And the function is defined for all real numbers. Part A says a portion of the slope field of the differential equation is given below, and we want to sketch the solution curve through the point 0, 1. So the idea being that here is the coordinate 0, 1, and so we would draw a curve, the function f of x, such that these would be the tangent lines to the curve. And so if we follow along, we would have a curve that would look like that there, and then down here, following along so that you have tangent lines, these short line segments. So the curve would look like that, where each of these line segments were tangent to the curve. Part B asks us to write an equation for the line tangent to the solution curve at the point 0, 1. So the idea being that we're trying to find a function value to the curve at point 2, but we're going to use the tangent line at a point close to x equals 0.2, which would be x equals 0, as an approximation. So there's two things that we need to write the equation of a line, or in this case a tangent line, and that is a point, and the point is 0, 1, and then we need a slope. And so if we go back to the beginning of the problem, we were told that the slope, the differential equation rather, dy dx equals the quantity 3 minus y times the cosine of x. And remember from earlier in the year, one of the applications of the derivative is it represents the slope of the tangent line at any given point. So here's our point 0, 1. So we're going to find the slope there by substituting 1 in for y, 0 in for x, and 3 minus 1 is 2. The cosine of x is 1, and so the derivative at the coordinate 0, 1 is equal to 2. So now we can write in point slope form the equation y minus 1 equals 2 times x minus 0. So again, this is the tangent line to the curve, to the f of x curve, at the coordinate 0, 1. And obviously the tangent line at x equals 0 is really close to the curve when x equals 0.2. And so we're going to use the tangent line to approximate the function value at 0.2. So we're finding a tangent line value at 0.2, which we believe would be very close to the actual function value. So we're going to substitute 0.2 in for x. 2 times 0.2 is 0.4, add 1, and we get 1.4. There's our approximation. Part C asks us to find the particular solution to the differential equation, again with that same initial condition. So again, we start with our differential equation. We'll use our separation of variables technique. So dy over 3 minus y is equal to the cosine of x dx for the antiderivative of both sides. Here on the left side, we're going to do a u substitution. So u is 3 minus y. Du is negative 1 dy. We don't have a negative in our integrand, so multiplying both sides by the negative leaves us with dy equals negative du. So now using our u substitution, dy is negative du. 3 minus y is u. And here on the right side, the antiderivative of cosine is sine x, and then plus c, right? Because we know the derivative of sine is cosine. The antiderivative here on the left of du over u is the natural log of u. There's our minus, but we do have to substitute in back for our u. to be absolute value. And now to solve for C, we go back and use our initial condition of 0, 1. So I'm going to substitute 1 for y, 0 for x. So we get minus the natural log of 2. We don't need absolute value there. Sine of 0 is 0, so C is negative natural log of 2. So at this point, I'm going to substitute that back in for C. I'll do that over here. So we have sine x minus the natural log of 2. And now we have to solve for y. So I'm going to multiply both sides by negative 1. And to isolate the y, we're going to e raised to both sides of the equation. That would leave us with the absolute value of 3 minus y. But we know that y of 0 is 1. We know y is going to be less than 3, so we don't need absolute value there. So we get 3 minus y. And then here on the right side, we have e to the negative sine x. And because we're adding, we can multiply like bases, right? Because here, if we were going to go backwards, we have e to the negative sine x, e to the natural log of 2. Multiplying like bases, we could add our exponents. So e to the natural log of 2 is 2. So we have 3 minus y equals 2e to the minus sine x. We'll add y, subtract 2e to the negative. Let's see, that's subtract 2e to the negative sine x, and we're left with y equals 3 minus 2e to the negative sine x. And recall in the beginning it did say that f was defined for all real numbers, and we do see here that we know the sign, which is where our independent variable x is located inside. The domain of that is all real numbers. So there is our final solution.